Okay. Okay, I'm ready. 8-4, day 2. Still going to find area between the two curves, bounded by curves, and just going to run into some different functions today. First one, we want to find the area bounded by the equation x equals 3 plus 2y minus y squared, and the other equation is x plus y equals -1. Okay, first of all, you got to take yourself back to advanced algebra. When you have the y that's being squared, yes, it's a quadratic, and when the y is squared, it's a sideways parabola. It's either going to open left or right. Or when the x is squared, they open up or down. Well, because this is a negative y squared, I know this is a sideways parabola opening to the left. Negative is left. If it was a positive, it would open right. Okay, so you can't type this into the graphing calculator because sideways parabolas are not functions. They fail the vertical line test, and our calculators only graph functions. So the trick that I'm going to give you is to give you a formula for the vertex, and then just you have to know whether it opens left or right and just redo the rough sketch. Because all we need is just a general idea of what it looks like, because we'll use the algebra to find our boundaries. Okay, so to get the vertex of a sideways parabola, you might want to star that in your notes because you'll be using it. You're going to figure out the x after you get the y with this little plug and chug. It says take the opposite of your b value and divide by 2 times the a. And the a and b are coming from any quadratic equation. The a is the coefficient on your squared term, so in this case my a is a -1. The b is the coefficient on your variable to the first term, first power, which this would be a 2, and then the c, which isn't even in here, is your constant. So the squared coefficient is your a, and then the single one is your b. So let's figure out what the y is for our vertex by taking the opposite of the b, that would be the opposite of 2, which is -2. Divide by 2 times the a value is a -1. So then what we've got is -2 divided by -2 for a +1. Then to figure out the x, you just have to put the 1 back in here. So it'll be 3 plus 2 minus 1, that's 4. So our vertex is at 4, 1, and I know it opens to the left. Okay, there's my vertex, 4, 1, opens to the left. Okay, my other equation is a linear function. I can graph lines if I get them y equals. I'd subtract x, so -x minus 1. So I know my y-intercept is -1. I don't know where that is right here, but again, it doesn't matter. I'm just going to throw it here. And then my slope is a -1. So I'm going to go up 1, left 1. Up and left. Oops. Continue this. Now I have a nice enclosed region. Okay, next thing you should do is draw your rectangle in. And so all day yesterday, your rectangles were vertical. And that's not a problem for, don't draw these, this part of my bounded region, because I'm hitting parabola line. But once I get past this intersection, now I've got parabola minus parabola to get me the height. Well, if I take the parabola and subtract the parabola, I'm going to get 0 for a height here. And I can see that it's not 0. So I cannot draw the rectangles in a vertical position with this kind of arrangement, because I run into problems over here because the rectangle makes the parabola touch itself, subtract from itself, which gives you a 0. Can't have that. So the only option I have is to turn these rectangles and draw them horizontally. Now you can draw this one. focus on this rectangle, and you can see all the way through this enclosed region, the horizontal rectangles would be touching the parabola on the right and the line on the left, all the way through the whole thing. So we need that consistency in order for this to work. Okay, now that the rectangles are sideways like this, you can see the width of my rectangle is no longer a dx, a change in x. This is the y-axis here. This is a dy. That's my width. And my height is laying down. Well, no, I don't want that yet. And so this right here is what tells me I need y values in my integral. So my boundaries need to be y values. So I want the y value here and the y value here. And my height is going to be determined in terms of y's. And we'll get to that in a minute. Okay, so sideways rectangles, dy, which tells me I want y boundaries. How do I find the boundaries? I still set my equations equal. Because if they intersect, that means they are equal at those 2 points. So I'll take my parabola, which is 3 plus 2y minus y squared, and set that equal to my line. But because this is in terms of y, I want the line in terms of y. In other words, I want the line to be x equals like the parabola is. So I'm going to rewrite it and kick the y to the other side. So that would mean x equals, subtract the y, negative y, subtract 1. Not going to use that. Set those equal. To solve that, I'm going to get it equal to 0 and then run my quadratic formula program. So I'm going to add y to both sides and add 1. So I'll add y to the 2y. I'll add 1 to the 3. 4 plus 3y minus y squared equals 0. Running my quadratic formula, a is always my squared term. That's a negative 1 in this case. B is a 3. C is a 4. So I get y equals negative 1. Y equals 4. Now I know my two y values. Right here, that actually crossed right on that y-axis. That's negative 1. Up here, this is up at 4. So now my integral then is going from negative 1 to 4. The width of my rectangle is dy. The height of my rectangle, okay, yesterday we were doing top equation minus bottom equation, but I don't have that situation. I've got them laying down. So this time the height is right function minus left function. So height is going to be right minus left when they're laying down or in the horizontal position. So my right function is the parabola. So that's the 3 plus 2y minus y squared. Then I have to subtract the left function, and the left function is linear and it has two parts to it. It's negative y minus 1. So I do need to have parentheses here so that both parts of the linear function get subtracted. So I'll distribute 3 plus 2y minus y squared plus y plus 1. Combining like terms, I'm going to pull the squared term to the front. 2y plus y is a plus 3y. 3 plus 1 is a 4. So there's my height. Times my width. Okay? I didn't need the parentheses there. It's to the first power. So now when I'm ready to integrate, I just do each term separately. So I do the little individual power rule here. So I add 1 to the exponent, multiply by the reciprocal. Add 1 to the exponent, multiply by a half or divide by 2, plus 4y, evaluate from negative 1 to 4. So you can type it into your y equals, use your table, 4 and negative 1. You're going to get 18 and 2/3 minus a negative 2 and 1/6. I did fractions. I probably just plugged them in and did them in my head. You can do whatever you like. And then when I end up adding here, I'm going to get 20, and then 2/3 plus 1/6. That's going to be 5/6. You can do decimals. I don't care. I'm more concerned about all this other process, not so much the exact answer. Okay, so sideways parabola. Try one more of those. Find the area. Bounded by x equals the quantity y minus 1 times the quantity y minus 4. And the other equation is the y-axis. Not really equation, but the other line is the y-axis. Okay, I don't know what this is yet until I FOIL it. Well, I kind of do, but I'm going to FOIL y squared minus 4y minus 1y plus 4. Y squared minus 5y plus 4. I know it's a quadratic. I know it's a sideways one, and it's opening to the right because it's a positive y squared as opposed to a negative y squared. I can't graph it in a calculator, but I'm going to remember that vertex equation. The vertex, I'll figure out the x after I figure out the y. And that formula was the opposite of b divided by 2a. So the opposite of the b is a positive 5. 2 times the a is a 1. So 5 divided by 2 is 2.5. If I plug 2.5 back in here, work that all out, you will get a negative 2.25. So to graph that, negative 2.25 up 2.5. There's the vertex. Opens to the right. Okay, the other function is the y-axis right here. So here's my bounded region. Next thing I need to do is draw in my rectangles, and I can definitely see I do not want them in a vertical position. That'll make the parabola touch itself. Don't do that. If I draw them in a horizontal position, I'm good to go. I've got the y-axis on the right and the parabola on the left. So now I know my width is a dy, that little distance. I need y boundaries, y1, y2, and I want my height in terms of y. So I need to set my equations equal so I can find these intersections. Well, I only gave you one equation right here, this parabola, but the y-axis has an equation to it. Think of the y-axis as a vertical line, and all vertical lines can be written in the same way. If I had a vertical line going through 2, it would be x equals 2. Going through 1, x equals 1. Going through negative 1, x equals negative 1. So the y-axis has the equation x equals 0. So that is the equation for the y-axis. Now I can set my two equations equal. Y squared minus 5y plus 4 equals 0. That's already in standard form. I can plug that into the quadratic formula to get my intersection. Oops, program. Okay. A is a 1, B is a negative 5, and C is a 4. I got 4 and 1.